Hi everyone, in this video I'm gonna go through the MA162 exam 2 of fall 2019. And for the first question, we are to find this integral. Since we can see that it's two parts, we can use by parts here pretty easily. So right away we can use Latte. And then we can get that we can set u equal to negative 9x and v to be dv rather to be cosine 5x dx, and in that way du would be negative 9 and v we can just integrate this, and then that should be just 1/5 sine 5x. And now we can just plug that into the by parts formula, and this should be uv, so negative 9 over 5x, that's a 5. 5x sine 5x would be uv minus the integral of v du, so that would be du would be negative 9, so negative 9 over 5 sine 5x dx. That's a 5 again, and we take this integral. So let me just this part will stay the same, but let's take the integral here. So negative 905 I can take outside. The negatives will cancel out for now, and then when I take the integral, it would be negative cosine 5x times 1/5, and that will be plus c. So in total we have this part for uv, and then over in the minus v du part we have the negative sign here, so negative 9 over 25, the 905 times 1/5, and cosine 5x plus c. So let's match the answers. It should be this one. It should be D, right? So both two negatives, x sine 5x. Yep. Alright, let's move on to question 2. Again, this has two parts to it, so we can use by parts pretty easily. And we can, for u, it's probably the best to use it on the log because of Latte. So u will be natural log of 10x, and that way du would be 1 over 10x times 10, which is 1 of x, and then dv would be 2x minus 1 dx, and v in that way would be x squared minus x. And we can plug it into the by parts again. uv would be x squared minus x times natural log of 10x minus the integral of v du, which is x squared minus x times 1 over x. And we can simplify this part once again. Then we will have inside the integral would be just x minus 1 dx, and that part would equal to half x squared minus x plus c. Oh god. Plus c. And we got to remember that there's a minus sign here. So when we have this as uv in front, then it will be minus x squared over 2 plus x, and plus c. Plus c, doesn't matter what sign it is, it should be just a constant. So we find the answer to be B here. So for question 3, we have a cylinder that's trying to, cylinder of water that we're trying to pump out from the top, and we can leave the answer in terms of all the constants, pi, g, and rho. So we first for some clarity, we can draw a diagram. So here's a cylinder, and the height is 7 meters with the radius of 2 meters, and we are supposed to find the work. So work is the integral of force times distance. And so like usually when we calculate something that the force doesn't change, the work is just force times distance. But when we have a changing force or changing distance, then we need to integrate it. And so from here, we can separate it into parts. Distance would just be the distance from top. So we can set the top to be 0 level, and this one would just be x. So it is x, and then the force would be the force of one slice of the cylinder. So it would be like a circle. One slice would be the area of the circle, which is pi r squared, pi times 4 from 2 squared, times g, the accelerator to gravity. And like this is because you're trying to calculate for just one slice, and the slice would be infinitely thin, so it doesn't have a height to it. Usually when you calculate the distance, it will be the volume, this should be rho, volume times, so it would be volume times rho times g. So since it has no height, this will just be an area, and rho makes it into a mass, and then times g would just be a force. So then here we can get that force of a selected slice would just be 4 pi g rho, and the distance will be x. So when we integrate this, it will be 4 pi g rho are all constants, so we can move it outside. This one will be x, and then we start from the top, so the top the bounds will be 0 to 7 as we try to pump all the water out, and then integrate this. So when we're integrating this, this should be a pretty easy integration. ignore all the constants, and it will be just 4 pi g rho times half x squared evaluated at 0 and 7. And then we can just plug the 7 into the equation. So I have space down below. So it would be 2 times 7 squared, which is 49 pi g rho, which would be 98 pi g rho, which is D. Okay, for question 4, the integral is pretty standard for a trig integral, which we have to do a substitution by the following equation of secant squared x equal to tangent squared x plus 1. So for the secant to the 4th power, we can separate that into secant squared times secant squared dx. And let's take the 7 out. And then for one of the secant squares, I'm going to substitute that with tangent x plus 1. dx. And then I will distribute the tangent squared plus 1. So then into 2 integrals. First integral will have tangent squared secant squared dx. And the second will be only the secant squared dx. So for the first integral, we can do a u sub of 10x equal to u. So taking the derivative would be secant squared dx equal to du. We can substitute this right here, getting 7 u squared du plus 7 times secant squared. The integral of secant squared is just tangent. So you can see here, if we go upwards, tangent x. So then here will just be 7 over 3 u to the 3rd plus 7 tangent x. And then we can just plug the u back in. We have 7 over 3 tangent to the 3rd power x plus 7 tangent x. And of course, there's a plus c. And that would result in our answer to be an E. And for any of the secant being a even power like this, this is the way to do it. You can divide each secant square into tangent square plus 1 and just separate it out and use this u sub right here, and it should be pretty easy to solve. And it's similar when you have a tangent. You should be able to just minus 1 for this equation, just minus 1 on both sides, so you get secant squared minus 1 equal to tangent squared. And do the similar thing over here, and it should resolve pretty easily. So for number 5, we're asked to evaluate a integral of sine to the 4th. This is somewhat different than the usual trig integrals, since it's a even power of sine. So we need to use the half angle formula of sine squared theta equal to 1 minus cosine 2 theta over 2, and cosine squared theta equal to 1 plus cosine 2 theta over 2. And I will need a lot more space to do this, so I'm gonna switch over to the whiteboard. The question is the integral of 5 sine 4 of 2 pi x dx. So first we can just use u sub to deal with the 2 pi x. So make u equal to 2 pi x. So therefore du will equal to 2 pi dx. And so we can bring the 2 pi out and the 5, the constants out of the integral. So so this will equal to 5 over 2 pi integral of sine 4u du. And the limit of integration, we can deal with that later. As I like to just u sub back in instead of calculating for the limits of integration for u. So in this case, I'm just gonna solve for this part of the integral and then tack the 5 over 2 pi in later. So for simplifying sine to the 4th, I'm going to separate that into sine squared u times sine squared u. And then I'm going to replace one of them with 1 minus cosine squared. So this would be sine squared u 1 minus cosine squared u. And then this would be sine squared u minus sine squared cosine squared. From there, we can use the half integral formulas. So sine square will equal to 1 minus cosine 2u over 2 minus, for these two, I'm gonna just bring the 1/2 out, so I don't have to have the 1/2 on bottom. So two of them would be, but both of them would be 1/2 times 1/2, so a 4th outside. And the first one will be 1 minus cosine 2u plus 1 plus cosine 2u. Usually it would be over 2, so I bring them outside as I said. And then further simplify the second part, I would have let's go over a little. Actually, I'm gonna split the first part into 1/2 minus cosine 2u over 2, so it's easier to integrate later. And for this, for this part, if you done a lot of math in like I think pre-calc, then maybe you can recognize that as the differences of squares. Or if not, you can just multiply it out. But in the end, when you multiply this out, you should get 1 minus cosine squared 2u. So again, we can use the half angle formula for this thing right here. And so this would be 1/2 minus cosine 2u over 2 minus 1/4 1 minus, so this time it would be, actually I'm just gonna, so I'm just gonna break the parentheses too. So that would be 1/4 plus 1/4 of whatever this thing is, which is 1 plus cosine 4u over 2. This 4u I got from, so if you remember the half-angle formula, so cosine squared theta would be 1 plus cosine 2 theta over 2. So in this case, I just plugged, theta is just 2u, so at that point it's 2 times 2u. So I get cosine 4u, and simplifying this more, we'll have so 1/2 minus 1/4, 1/4 right here, minus 1/2 cosine 2u plus 1/4 plus, so that's 1/8 of cosine 4u. So in this case, it would be 1/2. Wait, hold up. No, that should be 1/8. This is 1/4 times in half, so that would be 3 over 8 minus 1/2 cosine 2u plus 1/8 cosine 4u. So this is the simplification of sine to the 4th u. So now we can integrate it. So if we just integrate this, so we get 3 over 8 u minus that would just be 1/4 sine 2u. Chain rule, when you take the derivative of this, you would have 2 times this, 2 times cosine 2u, and then outside would result in a 1/2. And same idea of with this, with chain rule, should be sine 4u. If you're not sure with the chain rule, you can always just do another u sub. It'll be a w sub this time. So like for this example, I can just plug w. I'll do a different color. So w equal to 2u. Then dw would just be 2 du, and then this whole thing will be minus 1/4 cosine w dw. You can just integrate this and you should get this. Plug the w back in for u, and it'll be same thing for this. So that will be integrated to a certain limit of integration. But right now, I will just plug it back in. Plug the x back in. So I had u equal to 2 pi x. That's too small. So 3 over 8, 2 pi x minus for 1/4 of sine 2 times 2 pi x doesn't like that, plus 1/32 times sine 4 times 2 pi x. For this, we can have the limit of integration of the original one, which is 0 to 1/4. And if we plug the limit of integration in, we can have so 3/4 pi times 1/4 minus 1/4 of sine 4 pi times 1/4 plus 1/32 sine 4 which is 8 pi times 1/4 minus 0 if you plug in here, sine of 0, which is just 0, minus 0, so it would be plus sine of 0, and then minus 1/32 times also sine of 0. So we can just ignore those three terms. And actually, when you do the math for these two, it will come out as sine of pi, and here will be sine of 2 pi. And if you know the sine graphs well enough, these are all 0, same as sine of 0 is 0. So you just need to remember that any sine of the integer of pi, sine integer of pi would be 0. So it would be 0 times 1/4, which is 0. 0 times 1/32, I guess, will be 0. So in the end, the integral would be what, 3 pi over 16. But we need to remember that there's still a 5/2 pi at the front. So if we multiply it in that, so the final answer will be 3 pi over 16 times 5/2 pi. So it would be 15/32. So yeah, make sure to just go back to the beginning and check the limit of integration, and like if you have du, plug du back in or something you put in front to make the calculation easier. Make sure don't miss those. And plus c's if it's a if it's applicable. 6, we are asked to use trig sub to evaluate the following integral. So let's start by drawing a triangle. A right triangle, in fact, and we can construct this part of the integral from the triangle. So we have something, a perfect square minus another perfect square. So I would put 64, rather 8 over here, and x over here. And then by Pythagorean theorem, this would be 64 minus minus x squared root. So now we can use this angle as theta, then the cosine of theta, rather the secant of theta, would equal to 8 over the root of 64 minus x squared. Since cosine is adjacent over hypotenuse, secant is just the other way around. So the hypotenuse over the adjacent side, and then from there we can set up the substitution. So we can see that if you divide the 8 over, so secant theta over 8 will equal to 1 over 64 minus x squared. And we also have the sine of theta will be equal to opposite over hypotenuse. And we take the dx of both sides, the derivative of both sides. We have cosine theta d theta equals to 1/8 dx. So dx just equal to 8 cosine theta d theta. Then we can plug all that in into the integral. Then we have the integral of secant theta over 8 times dx, which is 8 cosine theta d theta. And from that, it will equal to, so the 8 and the 8 will cancel out. Secant is 1 over cosine. So all of it would just be the integral of 1 d theta equal to theta. And then we can substitute theta back in. So theta from this equation up here would be theta would equal to the sine -1 of x over 8. So we can plug that back in. So it would be theta would be the sine -1 of x over 8 evaluated from 0 to 1. So we plug 1 and 0 in, it will just be sine -1 of 1/8 minus sine -1 of 0. Sine -1 of 0 is 0 because sine 0 is 0 is 0. So we can just cross that out, and that should give us the answer of C. So this is the end with all the answers to part 1, question 1 to 6. Let me know how you think of the new version I'm doing. I'm trying to edit question by question and try to get better quality. Also, I'm using an iPad instead of writing on a computer with a mouse. So my handwriting is still pretty bad, but let me know how you feel about it, and stay tuned for part 2. Thank you.